Mars. A cold, dry, and barren world. When most people think of the red planet, they imagine endless deserts of rust-colored dust, whipped by fierce winds beneath a thin atmosphere. But hidden beneath the surface, and even preserved inside craters, Mars tells a far more complex story. For decades, scientists have known that Mars once had water. River valleys, lake beds, and even the suggestion of ancient oceans all point to a wetter past. But water still exists on Mars today, locked away as ice. And recent discoveries show that this ice isn't just frozen in place. It holds a record of Mars' changing climate. Buried in the mid-latitudes of Mars, within giant craters, lies a frozen archive. These craters preserve layer after layer of ice and dust, stacked over millions of years. Just like the rings of a tree, or the ice cores drilled from Antarctica, they hold a climate history, one that tells us Mars has experienced its very own ice ages. So how do these Martian ice ages work? What secrets are locked in the ice layers of these craters? And why do they matter for the future of human exploration? Let's dive in. To understand Mars' ice ages, we first need to look at its climate. On Earth, we experience climate cycles driven by a combination of factors: changes in our orbit, variations in Earth's tilt, and even wobbles in our axis. These cycles, known as Milankovitch cycles, help explain the rhythm of Earth's ice ages. Mars, however, takes this to another level. Mars doesn't have a large moon to stabilize its tilt the way Earth does. Because of this, Mars' axial tilt, also known as obliquity, can swing wildly. While Earth tilts about 23 degrees and only changes slightly over long periods, Mars can tilt anywhere from around 15 degrees to more than 60 degrees over millions of years. These dramatic shifts change how sunlight hits the surface, and that changes where ice can survive. At times, ice retreats to the poles. At other times, ice migrates toward the mid-latitudes. These shifts drive Martian ice ages, cold periods where glaciers expand far from the poles, followed by warmer times when ice melts or retreats. The result? A planet whose surface is constantly reshaped by cycles of ice, dust, and climate change. So where do we see the evidence of these Martian ice ages? The answer lies in the mid-latitudes, regions between about 30 and 60 degrees north and south of the equator. Here, scientists have discovered craters filled with layered deposits of ice and dust. These aren't just ordinary craters. They are natural refrigerators. The walls of the craters shield the ice from sunlight, and the thin atmosphere prevents rapid melting. Over millions of years, new layers of ice and dust accumulate. The result is a frozen stack of history, preserved in plain sight. One famous example is Korolev crater in the northern hemisphere. Nearly 80 kilometers wide, it holds a massive sheet of ice more than a kilometer thick. While Korolev itself is a giant reservoir of ice, many smaller craters across Mars' mid-latitudes preserve layered ice deposits that are more like records, storing alternating bands of dust and frozen water. Each band tells a story: a shift in climate, a change in Mars' tilt, a movement of ice across the planet. By studying these layers, scientists can reconstruct Mars' past just like we study ancient ice cores here on Earth. But how do we know what's hidden beneath the surface of a Martian crater? We can't simply drill kilometers into the ice, at least not yet. Instead, scientists use radar instruments carried by orbiters. Two key tools are SHARAD, aboard NASA's Mars Reconnaissance Orbiter, and MARSIS, on the European Mars Express spacecraft. These instruments send radar waves that penetrate the surface. Depending on the material, rock, dust, or ice, the radar bounces back in different ways. By carefully studying the echoes, scientists can build cross-sectional images of what lies underground. What they found is astonishing. Many craters show clear, repeated layers beneath the surface, bright and dark bands alternating in patterns. These layers match the expected rhythm of climate cycles driven by Mars' changing tilt. In other words, Mars' ice ages are not just a theory. They are written into the frozen ground itself. On Earth, scientists drill ice cores in Greenland and Antarctica to study past climates. Each layer of snow and ice traps tiny bubbles of air, dust, and chemicals, revealing the story of our planet's atmosphere. Mars doesn't give us air bubbles, but it gives us something just as valuable: dust layers and ice stratigraphy. As the tilt of Mars changes, ice shifts from poles to mid-latitudes and back again. During times of high tilt, ice migrates away from the poles and collects in craters. Dust storms, which are common on Mars, sprinkle layers of fine material across the ice. Later, during lower tilt, ice retreats and a different layer forms. Over millions of years, this creates a frozen stack of alternating ice and dust, like the pages of a planetary diary. By measuring the thickness and sequence of these layers, scientists can estimate the timing of Mars' climate cycles. Some craters preserve hundreds of millions of years of history. So what do these icy archives actually tell us? First, they show us that Mars' climate is anything but stable. The planet swings between different states, redistributing water across its surface. At times, Mars may have been icier than it looks today. At other times, glacier melted, leaving behind valleys and channels that we now see as evidence of liquid water in the past. Second, these layers help us understand the timescale of Martian ice ages. Evidence suggests that major cycles occur roughly every few 100,000 years, tied directly to changes in tilt. Third, the ice tells us something about dust, how it moved around the planet, how storms deposited it, and how the atmosphere interacted with surface conditions. This gives scientists valuable insight into not just the past, but the present-day climate system of Mars. In short, Martian craters aren't just scars of impact. They are natural libraries of climate history, holding a frozen record of millions of years. Understanding Mars' ice ages isn't just a matter of curiosity. It has real implications for the future. For one, water is survival. If humans are to live and work on Mars, they will need access to water, for drinking, for farming, and for making rocket fuel. The layered ice deposits in mid-latitude craters could be future reservoirs for explorers. But there's more. By studying how ice moves across Mars, we learn how stable these deposits are. Will they remain in place for thousands of years, or will they vanish as the planet's tilt shifts again? For colonists, that could be the difference between thriving and struggling to survive. And finally, the study of Martian climate helps us put Earth into perspective. Mars shows us what happens when a planet loses its atmosphere, when its climate cycles run unchecked, and when ice and dust dominate the landscape. In many ways, it is a cautionary tale, and a fascinating parallel to our own planet's story. When we step back, Mars reminds us of the fragility and complexity of planetary climates. Earth's ice ages shaped our history, carving valleys, influencing ecosystems, and even steering human evolution. Mars' ice ages, preserved in craters, tell a different story, one of a planet that shifted dramatically, freezing and thawing across eons, but never quite sustaining life on the surface as we know it. Every layer of ice is a message from the past. A record of a world that once had rivers, perhaps lakes, and possibly even habitable environments. And every discovery brings us closer to answering one of the biggest questions in science: could Mars have once supported life? The study of mid-latitude craters is more than geology. It is detective work across time and space. A way to reconstruct the story of a planet that is both alien and strangely familiar. So the next time you picture Mars, don't just think of deserts and dust storms. Imagine the hidden archives, the frozen libraries buried inside craters. Imagine the cycles of ice, driven by the tilt of a restless planet. And imagine future explorers, drilling into these deposits, reading Mars' history layer by layer. The story of Mars is not finished. Its ice ages are still unfolding. And deep within its craters, the red planet is still keeping secrets, waiting for us to uncover them. Because Mars is not just a dead world. It is a world in motion, a world with a climate, and a world with a past that we are only just beginning to understand.